Hello students. In lesson number 8, in the numericals we were doing. So further, example 8.3. The question is as it is, Usha swims in a 90-meter long pool. Okay, in a swimming pool, Usha swims. And the length of the pool is 90 meter. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Okay, so it starts from a point, it travels 90 meter and then comes back 90 meter along the same path. Okay, so it travels total 90 plus 90, 180 meter and back along the same straight path. Find the average speed and average velocity of Usha. So we need to find the average speed and average velocity. So what data we have right now? Total distance. For average speed, we need total distance. So total distance is equal to 90 and come back 90. So 90 plus 90, total 180 meter. And this traveling is done in total time 1 minute. So we need to convert. See, distance is in standard unit, so time also should be in standard unit. So we need to convert this minute to second. So 1 minute equals to 60 seconds. So average speed we can find. We have the formula for average speed. V average is equal to total distance upon total time. So total distance is 180 meter upon 60 seconds. So we can cut this 60 3 are 180. And so V average is 3 meter per second. So average speed for Usha is 3 meter per second. Same way we can find the average velocity. Average velocity VAV is equal to, instead of distance, for velocity, it is a displacement term is used. Okay, total displacement upon total time. So displacement upon time taken. So here, what is the displacement? We know that displacement means the distance between the initial point and final point. So understand here, Usha starts its motion from one point, it travels 90 meter and come back to the original point. It means that its final and initial point is same. So the distance between final and initial point is 0. Okay, so there is no displacement because its final point, it comes back on its original point. Right? So displacement is 0 meter upon time is 60 seconds. So 0 upon 60, that means 0. So the average velocity is 0 because the displacement is 0. So this is example 8. Now related to this, in the same topic, on the page number 102, there is an in-text question answer, and in that the fifth one is a numerical. So numerical, I will give you here. So question 5. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. Okay, spaceship are rotating around the Earth. So from spaceship, one signal is traveling and reaching to the ground, where at the station it is received in 5 minutes. Okay, so it takes 5 minutes to reach to the ground. What was the distance of spaceship from the ground station? So how much distance from the ground the spaceship was? The signal travels at speed of light, that is 3 into 10 raised to 8 meter per second, and the speed of signal of speed means the speed of traveling of the signal is 3 into 10 raised to 8 meter per second. That is the speed. So this is the question. See, this is the Earth. We can illustrate like this. This is Earth, and from the ground, one spaceship is rotating around the Earth. One signal starting from the spaceship travels to the ground, and this traveling is taking 5 minute time. So this distance we need to find out from spaceship to ground. Time is given 5 minutes and speed of this signal is given 3 into 10 raised to 8 meter per second. So you can see here that speed is given in meter per second. Okay? So here the time unit is second. In every question, in every numerical, the unit should be equal for the quantities. So here time is in second. So here time should also be in second. So we need to convert minute to second. 5 minutes, how to convert in second? Multiplying with 60. So 5 into 60 equals to 300 seconds. Okay, so we'll use that. So distance we need to find. See, V and T is given and distance D we need to find. This traveling of signal is a uniform motion. Right? It is not doing, it means it will be a constant speed motion. It will not be a non-uniform motion. From spaceship to ground, it will travel with a constant speed, a simple speed formula. See, wherever there is a non-uniform motion, we should use the average speed formula. But here, it's simply a speed formula, that is speed is equal to distance upon time formula we can use. V is equal to distance upon time, d by t. We need to find d, so we can make the subject of formula d. So t is a denominator, when it goes to that side, it will go in multiplication with v. So ultimately, the equation becomes d is equal to v into t. Put the formula for v and t, that means speed and time. Speed is 3 into 10 raised to 8 and time is 300. 3 into 300 becomes 900 into 10 raised to 8. Now 900 we can write as 9 into 100. 100 is 10 square. Right? Understand here properly. 9 into 10 raised to 2, that is 900, and 10 raised to 8. Wherever there is a same base and there is a multiplication sign, power is added. So ultimately it will become 9 into 10 raised to 10, and it is a distance. So unit will be meter. So how much distance the spaceship is? 9 into 10 raised to 10 meter. And if we need the distance in kilometer, then how to convert meter to kilometer? Dividing with 1000. So 1000 means 10 raised to 3. 10 cube means 1000. So in division, when there is a 10 raised to 3, then the power will be subtracted in division. So 9 into 10 raised to 7 kilometer. So spaceship is at the distance of 9 into 10 raised to 7 kilometer. So this is how in formula some of the quantities are given and one quantity will be remaining to find. Okay, so by choosing a particular proper appropriate formula, you can find the required quantities. So in the numericals, it's okay if you write this numericals, write the question in random manner. Okay, just give the page number and proper question number to write. Okay, you don't need to write in a sequence. If you write in a sequence, that also okay. Okay, so still, if you have any doubt, you can ask me. Thank you.